So hello guys and welcome back to this one. Exciting news. We are done with the recursion series and solving recursion problems strictly, and we're back to the book. And on the book we are in chapter 8, where we are going to be talking about singly linked lists and the problems around it and how to make use of it. And for that, we are going to be needing some helper tools to help display answer, show some interaction between normal lists and this kind of list. And we're going to be using a list node that will be defined with data and the next pointer. Basically, the data is obviously the value to be holding, and then the next pointer pointing to whatever stuff we want this node to be pointing to. So we have this SQL helper build linked list, helps us build a linked list from a normal list. So basically it just allows us to build, have get pass in a list and then build it to help us build a linked list. And then we then have one guy that's going to help us move a linked list to becoming a list. So we pass in a node and it's going to iterate through the node and all the subsequent nodes and returns us the values inside and append inside the list, and basically that's it. Now our first problem says write a function that takes L and F and returns the merge of L and F. Your code should use O of 1 additional storage. It should reuse the nodes from the list provided as input. Your function should use O of 1 additional storage as illustrated in Fig 8.3. The only field you can change is a node. A field you can change in a node is next. So basically it's talking about the pointer, right? So this is the main problem, but before getting into it, I just wanted to do something, how would I say, something different, or something that will help us get into the solution more readily. And what do I mean by that? I'm going to solve this implementation using a normal list, two normal lists for that matter, and then subsequently we then going to see the usage of linked lists to solve the problem. So this problem gives us two lists and says the two of them are sorted. Can you merge them together so that the C remains sorted? Basically, we look at our edge cases where maybe one of the lists is empty. What do? We just return the other list. Since it's already sorted, there's no need to stress. So basically these two lines handle that for the first and the second list. And then if the list is a none, or if each of if two of both the lists are none or empty lists, right? Basically we just return an empty list as well. Then in our third line where we do a merger, we just join the lists together into one list, and then we recursively go through the list from, or we iteratively go through the list from first index to the last index of the list, and we basically do a swap between indexes from the first index down to the last index if and only if the index previous is greater than the index in front of it. And this is actually called a concept in EPI. So if you are familiar with that concept, please drop your comments in the comment section before I carry on. Now I say return list first list, and then after all said and done, we then return the first list and pass and return the first list, which is now holding the content of the two lists sorted. Now let's go ahead to see how that implementation goes on in our with our debugger to show us insight into what's going on. So let's see. So let's get into the function. Now we go through the edge cases, and then we are here where the way they store them are meshed together, and we're looking at here we will see that in really to change, and our first list becomes a measure of the two of them. And then we go into this and we have index at 0. So we continue again. Now I should be here. I will see the first list begin to change. So you see that the first list now, as this index has just been swapped with this one because this one is greater than this before, and we continue again. We could see here again the 6 is swapped again, and basically it continues in that manner till the end of the list, where we now have the first list fully functional, and basically uh, and it returns us our distance basically, right? So it returns us our sorted list from the two lists together. And basically, that's just the implementation of this guy. And if you care to know what this is called, it's called the bubble sort, where this guy goes through and sorts stuff over the trees. And that's basically it. So see you on the next one. Muchas gracias. Auf Wiedersehen. Tschüss.